There are a couple different methods in order to solve systems of equations. In this video, we're going to be looking at specifically graphs. You're going to have, really we're going to be looking at 4 different ways to solve systems of equations. There's graphing, there's substitution, there's elimination, and then solving systems using matrices. So with that being said, graphing is one of those, if you know how to graph and you're really good at graphing, this would be the way to go. If you're not exactly confident in your graphing, I would suggest using another method. But with this, there's some background that we need to talk about first before we can actually get into an example. The first thing, you have 3 different options. You can have no solution, you can have one solution, and then you can have infinite solutions. Okay, and this doesn't matter whether you're graphing or using substitution or elimination. These are your options. You have 3 options. When a system has at least one solution or more, this is what we call consistent. Therefore, a no solution is going to be inconsistent. And finally, last but not least, if a system has one solution, it is considered independent. If our system has no solution, it's considered, infinite solutions, it's considered dependent. With that being said, a no solution doesn't have the dependent or dependent option because it's inconsistent. We need to differentiate between the consistencies because we've got 2 green consistents, so that to differentiate between the 2 we have independent and dependent. So let's talk about graphing in general. Actually, we'll leave that up there. Graphing for a no solution. I'm just going to draw you a nice little picture here. Graphing a no solution means that you are going to have 2 lines that never intersect. Let's see, what are those lines called? Those are called parallel lines. Alright, if it's one solution, that means my graph intersects exactly at one spot. And last but not least, if we have infinitely many solutions, it's the same line. Okay, so that makes sense based on our pictures. I'm going to go through a refresher though with you on graphing, and then I'll get into Desmos and we'll just do it from there. That way it's a little bit easier and a little bit faster to go through. So for starters, let's say that I've got 5x minus 1y equals 3, and then I've also got y equals 5x minus 3. So I'm going to graph the first line. I'm going to stick this with red. And when I graph, you can either graph it from the y and x intercepts, or you can change it into y equals mx plus b. I like to change it into y equals mx plus b. I think it's a little bit easier to graph. Plus, you kind of have an idea then whether your slopes are the same to say that there's going to be a no solution, or you have the exact same equation to give you infinitely many solutions. So I'm going to go ahead and rearrange this. So I've got -1y equals -5x plus 3, divided by that -1, y equals 5x minus 3. Hey, if I noticed here, those are the exact same equation. I know right now this is going to be infinitely many solutions without even having to graph. However, I still want you to graph it, so I'm going to go ahead and graph the red line. Based on our graphing, we know, in case you need help with this, I'll write down the steps. Plot 0, comma b, so in our case 0, -3. Second step, use the slope. So our slope is 5/1, which tells us we'll go up 5, right 1. And connect. I already know that these are going to be the same line, so I'm not actually going to graph the blue one, just because I already know my answer is infinite. So because it's infinite, we know that this is consistent, and we also know that it's dependent. Okay. Now, let's look at something else where we can actually see what's going to happen if we have a one solution. Infinite and no solutions are a little bit easier to pick up on based on your y equals mx plus b. But when you actually have a one solution, it's a little bit harder to see if your graphing is off, where the point actually intersects. Now, these are my two equations. I'm not exactly sure if Desmos will let me just type it in that way, or if I'm going to have to rearrange it a little bit so that it's a y equal, so this will be quite the adventure. So, if we're on Desmos here, let's see what happens, if it'll let me do it. Hey, it actually works. Beautiful. So then I go and type in my second equation. And that is supposed to equal -2. So looking at this, I can see here that my graphs, my two lines intersect. My goal to find that one solution is to figure out where they intersect. So the great thing is with this, you can actually just hover over it and it'll tell you it's at -4, -2 is my intersection. So that's my one solution. Because it's a one solution, we know it's consistent and it's independent. You can find the intersection of two graphs based on the graphing calculator. We'll talk about that in class.